Multimodal Weekly webinars hosted by the teams over 12 hours. And we've been meeting every Friday at 1:30 p.m. Pacific time. Here are some of the topics that we cover every week, ranging from research and applications of multimodal AI to interesting video projects and infrastructure to support this kind of application. Occasionally, we have our team members come in and deliver talks about our perspective on this space, or tutorials on how to use the Toolapps API. Here is the slide of some of the previous speakers that we have. Today we have two speakers. First one is Alfredo, who will talk about his work with drone AI service, especially on industrial metaverse and fire detection. And then for the second half, we'll have Frank from Zilliz, who will talk about like a broader survey about vector database, the application moving from language to multimodal. Quick logistic, feel free to send your question on the chat, and the speakers can answer them asynchronously when they're not presenting, and then we'll have a brief 5 to 10 minutes Q&A session towards the end of at the top of the hour, once both the presenters finish with the talk. So with that, I'll let Alfredo share his screen so we can get started.
All right, so I'm going to share it right now. Let me see if you are already watching it.
Yep.
All right, so I'm going to start. Hello, my name is Alfredo Lagleyze. I'm CEO of Drone AI Services. And in the next 15 minutes, I will try to show our view on industrial insights of the future. First of all, I want to say that I'm not trying to bring a technical view of the state of the art of this, because it's more what we need about a fresh idea and new approaches to embrace this future than the technical view that comes with those good ideas to develop. And if I just get one spark from this presentation, I will be very glad to know it. Said so, let's get into it. And the whys, why we think the industrial metaverse is not only being developed, but a possible desirable future. For what we understand, it is becoming a game changer for operational technology on very productive assets. Of course, you may understand that all the big assets we use on daily basis, electrical grid, gas pipeline, factories, or wind turbines, whatever, or any other big assets, must be not only operated, but also maintained. And that comes with a huge on-field work, boots on the ground, they say. So with the fourth industrial revolution, this industry 4.0, we are facing a digitalization of these on-field operations, making some history a little bit. Until now, the last 50 years, we have been digitalizing management with software, tools, apps, email, spreadsheets, internet itself, etc., doing a great job. And now it's time for the operative issues to be digitized, with a big push on our actual huge computing power capacities that are already mature and scaling, of course, going up this ramp. 3D is becoming the new normal, and the convergence of all this maturing technology is fueling this growth. The market opportunity is huge, and the amount of investment capital that is going into this particular space is very, very significant, I have to say. Let's go to the next one. So the evolution of metaverse our development of the social with Meta, we can say. With the pandemic came the enterprise metaverse, and now the industrial, which in terms of economics, as you can see in this graphics, is the most promising one. So because getting to the metaverse will take more than sophisticated devices, though, it will need a collaborative effort. Nobody will actually own or dominate this metaverses. For example, this huge app development that it's going on right now with software as a service is already helping more organizations access the industrial metaverse and in turn facilitate agility and rapid innovation. Going back a little bit about these three different metaverses, we can say that the social one revolves around gamified use, entertainment texts, and social interactions, of course, while the enterprise is focused on business impact, changing how organizations operate and collaborate in digital immersive environment, boosting productivity, of course. And finally, the industrial one, dedicating to optimizing processes and enhancing efficiencies, driving innovation to areas like manufacturing, internal supply chain management, and logistics, of course. And the question that arises is how to access. While in social and enterprise, the entertainment or the information can come in the form of games and dashboards, the industrial matter is more of the same in some way, but the approach have to do with an engineering view, of course. So in these places where digital twins comes to play. And what is a digital twin? It's simply a digital replica of a real asset. As a basic concept, we can say that a spreadsheet with a geographic situation and technical description of parts of an asset can be a simple digital twin, of course, very basic, very simple. But today, the evolution of data gathering techniques like remote sensing, what we do with drones and different sensors combines not only an added CAD design with exact measures and systems interaction understanding, but also industrial Internet of Things information, telling us the real-time situation of that operative assets. So where does this process start? Simply trying to bring with a survey, with an inspection, this replica to the digital world. I can show you a 3D of an electrical installation where a person seated in the office will decide what and how many people is needed to do some interaction, some maintenance, what are the tools and logistics, and how this infrastructure will be dismantled in an eco-friendly way. The cycle I show here specifically is from Digital Twin Organization, and I can invite you to take a look at it. It's digitaltwin.org, so simply. This cycle where you can see how communication start in the first drawing, start between the physical object and the digital replica, where it is manual in the beginning. The modification in the state of either entity does not automatically reflects on its counterpart. But when data flows automatically from one to the other, with this surveys, inspection, IIoT overall, we witness the concept of a digital shadow. It shows real-time information situational awareness, but not the other way around. I mean, only one way. When we finally go to the third drawing, where you can see this replica automatically triggers information and actions like maintenance, cruise, going someplace, and or any other activities that are done, again, boots on the ground or by robotic means also, on the real asset, there is where we can call it a definitive real digital twin. There are various applications of digital twin in architecture, engineering, manufacturing, and the rest of the industry, with the technological advances taking place in IoT and artificial intelligence. Digital twins are also increasing interest, for example, for smart cities that have to copy the situation of a city. And what we ask is how this affects to humans on the loop. Well, it does definitely for worker safety, this interconnections with people on the ground doing the 3Ds, not the 3D, but the 3Ds are dirty, dangerous, and demanding tasks that can include our machine interactions now and more in the near future. I invite you to take a look. There's plenty of literature. The one I like the most are from MIT Professor Thomas Malone, and recently Kate Darling with her book, The New Breed, where she brings example of human-animal interactions as a good way to understand these relations. It has a lot to be with older workers that go out of operation with a lot of technical knowledge, and the new people with less of that, of course. Metaverse technology is being used for training an operator on how to drive a truck or open a valve or turn on a machine with these 3D glasses that can teach so in a visual, more understandable way. It's much more easy to see it. So in this way, sensors in the radiometric spectrum, let's say different sensors that can understand different things, and with edge computing power, we will be able to simulate many of these possible situations where a big wind or a high temperature can affect and take down an asset. So we can take measures to avoid it. This is why we say that we can unleash true potential of assets and their life cycle, of course. When we talk about this digital twin, we are talking about how to make the whole operation better, optimizing it. Whenever we can detect and or predict this failure, we are using less resources or affecting it. This is why predictive maintenance can eliminate unplanned downtimes, and today it can do so using machine learning and deep neural networks. Well, that's very important. Like 12 Labs creating their foundational model for video understanding, we can say that using sensor data recording captures reality and enhancing machines' capability to understand these failures. Recognition will be a great gain on any simple operation. In doing so, we also found that using synthetic data, for example, to aid the development of machine learning is in the data production, it's more accurate on labeling, and the flexibility to be adjusted as needed to improve the model give us more usability as a substitute for data that contains sensitive information, for example. And to end with all this, I want you to take a big look on this electromagnetic spectrum, because what I can say about this is we in videos, in photos that we do and we offer to our customer normally, we say, well, we can give you 3 million photos about an asset, but you will need something to understand it, to make the decision intelligence, you know. And in all this electromagnetic spectrum, you have a huge amount of sensors that can be used to reflect reality, to communicate that to data-driven companies. You can see the place of the visible light. What we use in photos and videos are a tiny part of this whole spectrum that can be huge if we replace it with many sensors. Okay, so that's what it is. Thank you.
Awesome. Yeah, thanks for going over such a wide array of technological concept, right? So you talk about like things like digital twins and the industrial metaverse and different type of tasks, and kind of how this technology can help improve some of the, I guess, physical work that had not benefited a lot from cutting edge technologies like AI as an example. Yeah. Awesome. Yeah, just one quick question from my end is like from kind of the company that you are working on drone AI. How does that what is your mission, and then how does that sort of like propel the your goal of bringing the metaverse to the industry? Yeah.
Well, really, this unleashing the true potential of an industrial assets and the infrastructures, optimizing efficiencies, making lean operation and extending the life cycle, the asset's life cycle, while paving the way towards a sustainable future and an eco-friendly dismantling of this whole assets is our mission in our works, mainly because engineers already have as a process to do this very efficient use of assets, and later on get into a process where they will be dismantling it through months or even years in some cases. So that has to be with the whole process. Our interaction with our customers today begins when they choose a terrain where they're gonna put a factory. So we make a survey of it. They can start building digitally to avoid any errors and to make calculation on times, on resources. Well, that's mainly our work. And later on, we continue with our surveys to show them what problems can be predictive, what problems has to be solved, with which level of criticity. I will say that's very important. The level of the critics' problems in this. It's not the same to have an electrical problem in a net of a neighborhood that when you have it in a production area that you may lose millions of dollars in minutes, So this is it.
Yeah. Just one, on another question, and then we can move on to Frank, more on the technical side of things. So you mentioned a bit about like synthetic data, right, and how that like can be beneficial for creating digital twins, right, and supported for a lot of these different industry use cases. How have you seen sort of like research in that area from a machine learning AI development? Like, what's been beneficial for your use cases, and then what do you expect to see more in the future? Yeah.
Well, mainly because we act in very different environments and have as we want to give a service or solution to many places around the world, we have many different, let's talk about one specific asset. Let's talk about electrical grid. You have different poles, different parts, different cables, different matters, different images that you have to treat those images in some attainable way. So synthetic image come as a very good resource to avoid that, plus all the other issues that help us with the labeling and many more. No,
Awesome.
That's mainly it.
Yeah, thanks for getting that tech. So yeah, I'll let Frank start sharing his screen for his talk. Also Manish asking a couple of questions in the chat. So maybe Alfredo, if you have time, you can respond to them asynchronously on the chat.
Thank you very much.
Yep.
All right. Yeah, thanks for the intro. Can everybody see that okay? The window that I've shared here?
Yep, I see it.
Okay, perfect. So thanks, first of all, for inviting me on this webinar. And today I'm going to be talking a bit about vector databases, and specifically a lot of the use cases and the variety of ways with which vector databases can be used beyond just doing semantic text search, beyond just doing retrieval augmented generation in conjunction with large language models, right? And before I dive a little bit too deep into this, I want to preface this short presentation by saying that, a lot of folks here probably are familiar with vector databases, and especially how you can use them in conjunction with LLMs. But I'll still try to go a little bit slower. I'll try to go over, what vector databases are good for. I'll talk very, very briefly about how LLMs work as well, just for anybody who's interested in catching up with all of this knowledge. Oops. So a bit about myself. My name is Frank. Director of Operations, ML Architect here at Zilliz, and we are a vector database company. We'll get a little bit more into the details of Zilliz in the next couple of slides. But before we do that, I want to go over a very, very quick agenda, right? So I want to talk first about who we are as a company, then I'll dive a little bit deeper into what a vector database is. And I have one slide that I'm going to spend quite a bit of time on that goes over vector database use cases. And specifically, I think you'll see that there are use cases not just in natural language processing, but also in computer vision, also in a lot of biomedical applications. I was talking to a friend recently about about some of those, all the way to building recommender systems, all the way to targeted advertising. And there are a variety of different ways that you can store data inside of a vector database. And hopefully through sections 2 and 3, that'll be a little bit clearer. Then I'll talk a bit about the future of search, right? And that last section will be a little bit more ML heavy, but again, I'll try to for a more general audience, I'll try to keep that pretty high level and really explain, hey, what are the things that we are looking at today, and where's the future of vector search and vector databases going? So who is Zilliz? Who are we, right? And we were funded in 2017. We've raised to date over 113 million, and we have a variety of open source projects that we maintain under our belt. The most well-known one being Milvus. Milvus is a it's an open source cloud native vector database. By, I would say, the vast majority of metrics, it is the most popular open source vector database on GitHub. Definitely feel free to check us out. I'll have a link at the very end. But we maintain a lot of other open source projects under the broader vector database / unstructured data ecosystem as well. Some other well-known ones are Toki, GPT Cache, and we also have an observability platform called A2 as well. So what is a vector database? Well, I'll dive right into the meat of the presentation here. And a vector database is really any type of data that can store, index, and search what we like to call unstructured data. And unstructured data can be anything, any type of human-generated data, images, video, audio, text, but there's a lot of other modalities, a lot of what I like to call less mundane examples of unstructured data as well. So for example, IoT data streams, you can have molecular structures, you could have geospatial data. These are all great examples of unstructured data. And we're only seeing more and more and more of this as time goes on, as we enter previous presentation was meant, we talked a little bit about, as we enter the IoT era, as we enter the era of everything just simply being interconnected, we have a lot more data being exchanged overall. And that really is what a vector database is there for, to store, index, and search unstructured data. But if data is unstructured, obviously there's no real great way to be able to fit it into, let's say, a relational database or an object database or a document database. And the solution to all of this, again, this diagram, I apologize, is a little bit simplified, but the solution to all of this is to use deep learning, specifically to use neural networks. And what we get from neural networks are these sort of intermediate representations that correlate very strongly with the semantics of your input data. I know there's been a bit of confusion around what embeddings are recently. Some folks say that it is a form of compression. Others say that it is just some way to semantically represent your input data. But ultimately, what an embedding is only as powerful as the model that you use. And oftentimes, depending on your application, you will want to use some different types of embedding models, which I won't get too much into in this presentation. But if anybody's interested, happy to chat offline as well. So, as I mentioned a little bit earlier, traditional databases, they can't do this stuff, right? You're not going to be able to store an embedding and be able to conduct a large-scale approximate neighbor search using something like MySQL or using something like CockroachDB. And really what you need is a purpose-built database specifically meant to store, index, and search these large quantities of floating point vectors. And that's exactly what a vector database is, right? It is meant to, whereas you have these vector search libraries that give you high performance vector search, you also have these advanced vector databases such as MILVs that give you a lot of traditional database features, in addition to things like metadata search, hybrid search, and advanced filtering as well. And ultimately, it is a database that is purpose-built for this era, for the era of AI, for the era of machine learning. And then, here's a slide also on how similarity search works. Again, as I mentioned a little bit earlier, as you have more data that is more similar to each other, will be closer to each other in this high dimensional latent space, right? So if you have embeddings that are that have very, very low distance, depending on your distance metric, oftentimes you use either L2 or cosine similarity, then these two pieces of data are very, very close to each other. And this property of embeddings, this property of trained neural networks, of trained ML models, is really what vector databases leverage to be able to give you this large scale similarity search. And again, another diagram sort of about how these embeddings work. I won't go too deep into this, but there's also the capability to do vector arithmetic and give you a very powerful semantic representation as these two, as to how two vectors or how 2 points in this high dimensional space are related. And I won't dive too deep into this slide as well. This is the MILVs architecture. Happy to talk more about this architecture to anybody after this presentation if you're interested. But what I want to spend quite a bit of time on is this one single slide that I have about vector database use cases. And what we've seen in the past, I want to say 3, 6, 9 months, is we've seen a huge surge in interest in one particular use case, which is semantic text search. And I've left that off here on purpose. And the reason is because semantic text search is commonly used in conjunction with large language models to inject domain-specific knowledge into that LLM, right? But beyond semantic text search, beyond retrieval augmented generation, there are a lot of other use cases for vector databases as well. Oftentimes, I think in the past couple of months, I think we've seen a huge surge in interest in using vector databases in conjunction with LLMs, but I think some of these applications have definitely fallen by the wayside. And when it comes to multimodal search and when it comes to multimodal models, there are more and more powerful ones out there that will help you build better search platforms and better semantic engines. And I'll cover some of these very, very briefly, right? The most interesting one that I think you can do, or the most basic one, I should say, that you can do is just simply image similarity search. So searching for similar images with a query image. And what that will allow you to do is, if I have, let's say, pictures of red cars or pictures of black cars, and I convert that into embedding, and I search for nearest embeddings in my vector database, I'll be able to get very, very similar results, right? I'm actually not sure if Google image search uses this right now. I don't think it does, but this is really a very, very powerful way to be able to do image similarity search. Same thing for video, right? Two very, very similar modalities in computer vision. By turning either fixed length video, so let's say 5 or 10-second video clips, or by, let's say, doing some type of summarization across the entire video, you can actually convert videos into fixed length embeddings and be able to do large scale similarity search that way. So I could search for, let's say, similar clips from TV shows or something along those lines as well. You also have things like audio similarity search, again, also a very similar domain as to computer vision, where computer vision, you really have two-dimensional, you have these continuous signals in 2 or 3 dimensions if you're using videos and image. For audio, it's very much similar, except it is one-dimensional, right? When it comes to beyond computer vision and NLP applications as well, you have things like molecular similarity search, the capability to turn molecules, to turn proteins, or to turn other molecular structures into these embeddings, and to be able to, let's say, do drug discovery using a vector database or other biomedical applications. Another powerful way to do so, right? And then you have others such as question answering, the ability to take questions and answers and map them to the same latent space is a powerful way to be able to give you high quality results. Recommender systems, if you have any type of user-generated content and you want to be able to recommend new pieces of content, a vector database is a great way to do that. And then anomaly detection as well. So oftentimes, if you want to do any type of fraud detection, it is one of the best ways to do that is to actually embed events and look at more recent events, really do similarity search across that most recent event to see if it correlates with previous instances of fraud in the past, right? So again, I know I sort of blazed through a lot of these applications, but really what I want to say is that there are a number of different use cases for vector databases and a number of different ways that you can perform vector search. And vector search itself is a powerful tool, but this powerful tool is not going to be able to help you unless you can connect a lot of these different modalities together. So for example, if I can connect images with molecular structures, or if I can connect events, in case of anomaly detection, with, let's say, audio snippets, there is not going to be a way for me to be able to really leverage all of the unstructured data that I have in, let's say, my organization or somewhere else, right? And that is really why, my last point is to say that the future of search truly is multimodal. And one of the final frontiers the final frontier, I think, for AI ML in general is actually not language models, as most people would believe right now, but it actually is video. And in particular, the capability for computers or other models to be able to analyze video in a very, very, in a self-supervised or an unsupervised manner, like we do as humans. That is going to be the ultimate, that should be the ultimate goal for a lot of, for the broader machine learning community. But I want to go through some examples of sort of some interesting research that's happening right now in multimodal search, and really potentially where that can take us in the future. And one of the older ones is actually DataTivec. Well, I say older, but I think it was released something like about 1.5 years ago. This is DataTivec 2.0, and effectively what's happening here is that you have these teacher-student networks, and the student network will learn. You will have either specific patches or specific areas inside of your input data masked, and the student network will learn to, it will learn to mimic the embeddings of the teacher network without that relevant input data. So, the diagram here, I think, explains it pretty clearly, where you do masking, and then the ideal situation is that you can learn the embeddings of the teacher network and be able to do sort of self-supervised learning that way. There's also PalmE from Google. PalmE is I wouldn't say it is a generic multimodal model, but what is going on here is that for a variety of different data modalities, and in particular for attention-based models, you can actually take whatever patches or other tokens, you can take those tokens and actually embed all of them into one sequence and be able to learn, be able to have all of those in one large language model. So this is where your inputs are multimodal and your outputs, you can potentially do some, let's say, question answering over them, or you could do some other application that you want to build as well. And the last one that I want to go over is a more recent one. This one's ImageBind, and it uses images or video as the central modality, and you can actually learn these representations from other modalities using images, or using computer vision, using these visual components as reference, right? I won't go too deep into sort of how these work, but that's hopefully, this is a good overview of where machine learning research and multimodal models has come from, and where it will be going in the short term as well. And I know I'm running a bit up on time here, so I'll sort of breeze through these as well. If you're interested in a vector database or getting started with one, we have a free tier on Zilliz Cloud. All you have to do is really go on Zilliz Cloud. There's a hosted vector database. We have a variety of different integrations, and we do plan to do an integration with 12 Labs as well. And then, we have a free tier, or you can actually just go and use Zilliz as the open source vector database itself as well. Zilliz Cloud is based on top of it. And we have a variety of connectors and other APIs if, depending on the language that you love using the most. So that is, I think that is all that I wanted to go through. Excuse me, getting a little bit tongue twisted there. And I'm happy to take any questions if there are any.
Awesome. Yeah, thanks for going over these concepts. We actually still have a lot of time because we only have 2 speakers today. So I think we can reserve some time for real-time question. The one that I see on the chat is from Michael. He asked, could vector search be a better method to search for audio fingerprints store as hashes? So do you have any response to that?
Yeah, in a way, you can think of embeddings as hashes as well. And really, when it comes to, we are seeing more and more applications in audio. But the main thing that I want to say about that is a lot of it is going to be dependent. So we are responsible, vector database is responsible for the vector search component itself. And as to whether or not a vector database will be better for a particular application, such as audio fingerprinting, is dependent on whether or not you can find the appropriate embedding model for your application. So for audio fingerprinting, what I would probably do is if I have a lot of my own data, I would train it in an unsupervised way to be able to, let's say, correlate to audio snippets with perturbations. So I would, let's say, run an audio snippet at 1.25x speed, or I would, up the pitch, and I would really try to minimize the L2 distance in a network that uses Siamese network, and I'd minimize the L2 distance for those two, for the original audio snippet and the perturbed audio snippet. Hopefully that'll give you a pretty solid way to be able to do fingerprinting inside of the vector database.
Thank you.
Great. So yeah, Niket, you have your hand up. Go for it.
Yeah. Thanks, James. Hey, Frank. I was kind of curious about, since you mentioned a bunch of different use cases, which were a lot of text-based ones for DNA genotyping. Yeah, when you went to different data types like image or video, did you have to restructure the database to be able to ingest different types of data? And does that change vector databases entirely, or is it just kind of generic? Like once it can work on any data type?
Yeah, great question. What I would say is that generally you want one collection or one index per model. And if that model is multimodal, so for example, there are a lot of models these days that connect images and text, or text and videos, so on and so forth, then you can use the same index or the same vector database for both of those different modalities. What it ultimately comes down to is if I'm doing video to video, as long as I have the same latent space, I don't even necessarily have to have the same model. So as long as I actually map both videos in the same latent space, I can use a vector database to be able to do large scale similarity search and analytics. So that's actually a common misconception. There are a variety of models especially a lot of teacher-student models, that actually end up embedding into the same space, and those you can use interchangeably. When it comes to more of the, that's also, I think, why I wanted to spend a bit of time on these multimodal models, is just to show that we are seeing more and more. This image bind is a great example is a great example. We are seeing more and more unique modalities being embedded into the same space. So for example, IMU stands for inertial measurement unit. In your phone, you have one, and it helps you figure out whether or not you're right side up or upside down, so on and so forth. And the ability to map IMU data into, let's say, text data is not something that you would think of right off the bat, but it's something that we can do, right? And it's something that image bind, I would say, has accomplished. And that is really leveraging these types of models, leveraging embeddings from these types of models is really what a vector database is meant to do at the underlying level. We provide the infrastructure and you provide the model, and then that is really all you need to be able to build something really, really awesome, to be able to build some, let's say, awesome search or awesome analysis application. Hope that answers your question.
It does, yeah. So there are ways to bridge the different data types over to, I'm guessing text is how vector data is all stored and indexed. So that makes sense. Cool.
Yeah, absolutely.
Nice. Jay, do you want to go first?
Yeah. So, well, thanks, Frank. Really enjoyed the session. I think I have a question about storing embeddings, that whole concept in general, right? I think we are in that phase where technology is still quite nascent, right? And we're seeing amazing models with different capabilities come out, and they might not necessarily be mapping into the same latent space, right? So how do you advise your customers that are looking into integrating state-of-the-art models and leveraging their embeddings, but then they're kind of nervous about in 2 weeks, there might be a new model with different embedding dimensions come out, and we've spent all of this dollars into, I don't know, storing tens of millions, even like hundreds of millions of embeddings onto Zilliz, right? And what are some of the research areas that you guys are looking into to mitigate this? And then maybe touch upon what are some of the most difficult challenges when it comes to like widely making this accessible to everybody.
That is a great question, and it's one of the areas that I'm interested in personally. And generally, what I advise folks either using Milvus or any other open source vector database, folks who are concerned about having previous generation embeddings and then the latest model, is I always strongly encourage folks to use open source models. And the reason is because as you have these different generational models, you can actually train, depending on the data modality and depending on the amount of data that you have as well, you can actually train these small autoencoders that help you jump from generation to generation. Now, I would strongly advise against, if you have multiple generations, to simply train autoencoders, to go from generation 0 directly to generation, let's say 7, 8, 9, or 10, because you do lose a lot of that describability later on. But that is my recommendation, is to actually pick a subset of your data set, train an autoencoder on top of those old embeddings to really remap those into the newest latent space. at certain checkpoints, you will have to reindex, you will have to recompute embeddings and reindex all of those embeddings, which is unfortunate. But I think at the same time, what we need to be a little bit better about is also backward compatibility for models as well. So whereas you have, libraries and you have other databases, relational databases that maintain backward compatibility through minor and patch revisions, we need to be able to do that. We need to have some sort of system like that for models as well, for machine learning models, some sort of revision system and the capability to, let's say, hey, I know V1 or V2 of this model is going to be backward compatible, but V3 and onward might break that compatibility. So, there's no easy answer to that. And I think that is, if you were to ask me in the broader vector search plus ML space, that's probably the most challenging problem. And one that I don't think anybody has a great answer to right now, but hopefully as a community, we'll be able to figure out, hey, what are the best ways to do it? What are the best practices?
Cool.
Nice. There's also a question on the chat. Alfredo, I saw you unmute. Do you want to ask anything or no? Okay. So there's a question from Soyoung on the chat about sort of this discrepancy between build versus buy, right? Being one model versus to your point, I think you just recommend like using open source, but what is the distribution of those in your experience?
Yeah, I think I think these days I want to say that as a part of the open source community at Milvus, I think we see probably more users than ideal using just OpenAI embeddings, which I will actually, I don't think there's anything wrong per se with OpenAI embeddings or the embedding model that is used there, but I actually recommend against that. And the reason is because you don't know, sure, there are these sort of, they have their Gen 1 embeddings, Gen 2 embeddings, they have, additive average query, but you don't know when. I think the problem with a lot of embedding endpoints is that you don't know when something is going to happen to that endpoint. I know there are a lot of different opinions about, let's say, machine learning API, models embedded behind an API, but that is always my strongest concern with any embedding endpoint, is that it's always unclear if that endpoint will still be there, 3 or 4 years down the road. And at the same time, it's also, you're also never sure you also really have no control over what the input, what the training data is, right? Whereas you do when it comes to open source models. I do realize that it is sometimes easier just to use a generic model if you're building an application, but I still recommend folks to invest a bit of time in looking at different open source models and using those with open source vector databases as well. So, I'm probably a little bit biased. I have to admit, I'm definitely an open source guy first and foremost, but that's just my 2 cents, right? That's just my 2 cents.
Great. Yeah.
Thanks.
You are welcome.
Nice. Any question from folks in the call in the meantime? We still have like 8 minutes left, so we can maybe open-ended discussion on some topics that based on the presentation of both speakers, right? Since we have to hear, we can discuss more in details. I guess maybe one thing from our end at 12 Lab is like maybe this one for Alfredo, but like, do you see any potential utilization of videos for drone AI? Just maybe curious to hear your perspective on how that can benefit some of the 3D, right? The 3D, right? You mentioned in your talk tasks with drone usage.
Yeah, definitely. Well, when we are doing our job, normally on-field operation, we are taking all the time videos, and to go back to analyze that information that you don't have already in a model, you have to go back with people taking a look on every single part of the process to watch a failure or something that it's not good. So the searching, this multimodal searching, will do a great thing for us, for sure. It does. In fact, we are start using this kind of tool. We are more focused on developing our own identification of this failure, but also we are trying to make easier operation on the actual analytics that we are doing. So yes, it does.
I see. Right. Yeah. Jay, do you want to do some discussion? Yeah.
I have a question for Frank. So when it comes to embeddings hygiene, what are some of the things that you kind of see that people kind of forget about? Or are there anything that when it comes to operating with embeddings, are there some sort of like a tech hygiene for managing your embeddings and the kind of mindset that you should have when you get into that?
So Andre Karpathy actually has an interesting tweet a while back, which is someone asked him, how do you store your embeddings? And he said numpy.array, which is which is absolutely true when it comes to embedding hygiene or embedding storage. I tell a lot of people, especially a lot of folks starting out, actually just not to use MOOCs or not to use any other vector database at all. Simply because if you have less than, let's say, 1,000 or 10,000 embeddings, you just want to store them locally. Just pickle them, and as you load them up, just do naive nearest neighbor search. You'll always get a 100% recall. And it's easy to implement, very, very low overhead. And as you are developing out a prototype, as you're developing out the application, it just makes sense. It's easy to do, right? Where a vector database really comes into play is when you need more of those database features, when you do need more general management of embeddings, and you do need very, very scalable approximate nearest neighbor search. So one thing that I didn't mention that I'm sure some folks here are aware of is that vector databases do not give you exact nearest neighbor search. The recall is not 100%, unless you use a flat index, which I don't recommend. When it comes to vector search, because it is very, very different from relational databases, what ends up happening is that you trade off a tiny, tiny bit of recall. So your exact, let's say, 100 nearest neighbors might not be a part of the output or part of the output query from the vector database, but instead you get a significant speed up by using, like a tree index type or a graph index type. Graph indexes are the most popular today, but you do get a very, very small hit in recall. And I think a lot of it, to me, I think even to this day, it is surprising that a lot of people don't know that, a lot of developers especially. And that's why I say, hey, if you're really starting out using embeddings, irrespective of the modality, don't use a vector database, right? Don't. And I know that sounds crazy for a lot of people. If you have 1,000 embeddings, or if you just have a data set of 10,000, pieces of unstructured data, don't do it. But once you start scaling, once you start needing those database features, once you start needing advanced, some hybrid search, you need more metadata search, that's really when it makes sense. And yeah, beyond that, as long as you can map your embeddings to the original data, and that's all you need, right? Just don't lose those mappings, and you'll be okay.
That's great. Yeah, I mean, at 12 Labs, I think as the models get better, our customers or users tend to forget about recall, but almost kind of, I don't want to say hallucinate, but kind of confused between detection problem versus search problem. And then what we're actually optimizing for is recall, but then they expect it to detect at a very high accuracy, right? So those are, I guess, inherent kind of like a gray area for embedding based search, right? So yeah, and then just curious, are you a big one model solves it all kind of a person, or do you think that we will, as the research has proven out, language models are great at reasoning? Will we see like many language models interacting with different series of language models and other foundation models in different modalities, kind of working together?
Yeah.
I guess it's one is OpenAI wrote versus one is all of the open source and some of the closed source systems kind of working together.
I think irrespective of modality, we're going to start seeing what I like to call waterfall models. And what that means is you will have simplistic models that are open source, that are, let's say, comparable to GPT-3. And I'm talking just about language here, not about video or any other computer vision or any other modality. But it applies to these other modalities as well. And that language model will, if, based on the response of that language model, you can then have some heuristics, which you will then go to a larger model. So you could go from, let's say, Llama 7 billion to 65 billion, as the mid-tier model. And then if still that particular model doesn't give you the result or the output that you want, that's when you go and call some of the most advanced ones. So that's when you call, let's say, the GPT-4 endpoints, or that's when you call, let's say, Stability AI's, image generator, or Runway ML's text to video. That's when you do that. And this waterfall model, I think, not only will help reduce costs, but it helps you improve latency as well, right? So you have, inference across transformers is expensive. It's really expensive. It's quadratic relative to the number of tokens that you have, and there's just a lot of work that needs to be done there, right? So that's why I think this is also going to be the way forward. It's not just going to be, hey, endpoints are dominant or open source is dominant. It's going to be a combination of both.
Cool. Thanks.
Absolutely.
Great, awesome. Is there any final question before we conclude? It's been a very engaging session so far. Okay, if not, thanks everyone for joining. As usual, we'll have the recording of this session available on our YouTube playlist next week. We'll send out to attendees who can rewatch